Testing.
Good morning, Rosetta. Sorry we didn't get your parts to you already. Well, we're sitting just shy of 50 people, Chuck, so we'll give another couple minutes.
Right. I just had to let my coworker in. She's
So
not
you got
at the door.
coworker to show in front of the camera?
Let me turn this light on.
Oh, look at that little guy. Now, if I
Mm-mm.
spotlight your video, it should be large for everybody.
Oh, she'll be here all day.
Oh, cute.
He said, put me down, put me down.
It's been a great time for pets the last 2 months.
I have a sleepy pug.
Can you demonstrate the sleepy pug?
Yeah,
It's right there.
Okay,
Oh,
good.
okay. Look at that thing.
He's sleeping.
Not a worry for that dog.
You think she'd be more excited? It's robotics.
Ashley, how's it going for you? You're muted, but I think
Doing good.
all right.
Doing
Looks like you accomplished quite a bit the last couple of days.
Yeah, I did. This is all brand new to me, so it's been very interesting.
It seems that you have some coding background from somewhere, though.
Very little. I've been working with drones with one of my elective science classes. We've just been trying to embed it kind of like a STEM spin-off kind of STEM program. But this is, and I've done a little bit with the Lego Mindstorms. My daughter is in the Lego Robotics Club at the elementary school, and I've done a couple of workshops with that just to see if it's something I would like to do with my middle school and high schoolers.
She'll never complain.
Yeah, excellent.
Again,
Just trying to
Brenda
find
has
all
a
kinds
good
of
question.
good new things to bring.
Yeah, great. Go ahead, Chuck. We'll got a minute, and then we'll do breakout rooms too. Or Kevin,
Yeah.
Tommy, whoever it was.
So I was going to say, Brenda said, she asked a question, should I have to flash the cyberbot.py every time I have the Cyberbot off for a while? It's a good idea just to make sure that it's there every time you're going to interact with the Cyberbot. And remember to plug in your Cyberbot and then click on the connect on your editor and then load save. And if you scroll all the way to the bottom on the load save, then you should be able to see that there are 2 files there generally. You want to make sure that cyberbot.py is one of those. If it's not, then go ahead and reload it. You shouldn't have to redo it if the bot's just been turned off, but it's always a good idea to make sure it's there whenever you're programming. But good question though. And I would encourage everyone to go ahead and do that. Make sure that your cyberbot.py file is loaded onto your microbit.
Did that. Oh, they won, May. They did the.
All right, Chuck, so you can go ahead and mute everybody. So for those still struggling with the adding the cyberbot.py, I'm just pasting a video into the chat right now that I made. The audio is not part of the video, but it'll show you how to add the library. Well, what do you say we all get started? It's Friday, yay! All right, well, kick things off here. We have a robot demonstration. So it's Friday. Okay, it's our last day of class today. What are we doing? Well, we're going to be busy. We're going to start out, Chuck has made some breakout rooms. So anybody who's having any kind of issues here, just tell us in chat and he will put you in a breakout room. We got a few people on board to help. Tommy and Chuck, Andy, and I believe Joe is here as well.
Yep.
So we'll start by getting the breakout rooms going so we can take care of any support issues. And then I'm going to address 4 questions that came up over the week. Actually, I had probably well over 100 to 200 emails from you, maybe 300, I don't even know. But I could see the progress was happening and I noticed some repetitive questions, so I'm going to answer those here. And then we're going to get right into cybersecurity with Andy at 20 after. And then Andy's going to take us up near the end, and then we'll do the award ceremony and any final wrap up. Anyone make a motion to second the agenda and we'll get on? All right. Saw a few smiles out there. Okay, so the first question that came up was adding the Cyberbot library. That's always common. I have a video for it here on YouTube. The link, once again, I'm just putting in the chat. There you go. And there is a different video for using Mu. I might even be able to show you that briefly if we have time. So next question was about memory usage. And I made a video for that as well. And it's right here. I don't know if you can hear my audio on YouTube, and I'm not going to play the whole thing anyway. So I'll just turn that down. But the bottom line here is the question was how much memory is in the microbit for Python code? And when I ask our engineers, it's just goes way over my head because they talk about heap space and the Python interpreter and how the microbit works. And so what I have been doing is writing programs until I run out of code space. It hasn't actually happened yet, but it could happen to you. So there are a couple tips I have in this video that I'm going to paste also into chat right now. So you can grab that and watch in the future. But the bottom line here is the following. A couple things I told you. One of them was about making comments. There are 2 ways to make comments. Hashtags or using block commenting. Hashtags are for lines, and then block comments are 3 apostrophes, and you can put in tons of comments. So I did a little test here where I went and got the Declaration of Independence, and I formatted it with hashtags at the beginning of each line and no carriage returns. And I pasted it into my program as comments at the bottom. You could see down here. And then I ran it and it compiled just fine. And I was not out of memory. So concluded hashtags and comments are not a problem. They're optimized out when you flash. So you can use hashtag comments and not eat up tons of memory. I did a second test where I took apostrophes and I did block commenting. So again, I took the whole Declaration of Independence. This time I pasted it in the bottom and I commented it with 3 apostrophes, as you could see here in the lower left of this video. And this consumed memory, and we think it's because those 3 apostrophes are interpreted as a string. So it's eating up what we call RAM. Not good. There is in your program, in the Python editor, if you go into load and save, and you scroll down to where it says show files, you can see this relative bar indicator. And I've been measuring memory in inches, but you could see this little teal color on the left, that's your modules. I'm using about 1 inch of module memory. And the main is your code, that's your Python script. And then you have all this free. So it's not entirely clear when you consume this free, but comments will consume it, but it will compile just fine if they're using hashtag. Apostrophes become a problem. Now, some of this memory, I believe, is also for data, storing information. So it's difficult to tell, and I have no real good answer for the question. But what you can do is write good code. Don't use block comments with the apostrophes, and use small variable names, and I think you'll be okay. And then there are further measures you can take by only importing parts of a library you need, for example. But I think this problem will actually resolve itself in time. Yep. Any question on that?
Calling Daniel Wilmot Mobile.
Okay, so moving on. Yeah, that video is in the link, so go ahead and watch it. Next, Jack had a great struggle, which we will use as a demonstration here. He wrote a program. Can you do some muting on them, Chuck? Thank you. Cool. You guys can unmute yourself anytime you want to ask a question. Just go right ahead. So Jack wrote this program that we're looking at, and it's an escaping corners program using whiskers. And he did this thing where he made a counter. It's this line of code, and he was incrementing it by 1 so that when he got to over 4, he would back up and then turn left and left and really get away from where he was stuck. And the program looked like it should work, but he struggled with it for 2 hours. And the issue lied down here, and it was not easy to see. And it was this else counter equals 1. So he did finally resolve it. And the problem really was how your if else's line up in your block code, and how it actually executes has everything to do with indentation. So he provided a working version, and 2 tips I have for situations like this that are difficult to resolve. One that's helpful is you can use a different code editor than this online Python editor, which is kind of minimal featured. For example, here's his same code in Mu, and I just pasted it in, and Mu has these lines that show you what's connected to what. And his issue, as he found out, was right here. Those if and else's had to line up. Otherwise, he was setting counter to 1 regardless in both the if and else, and this program never actually ran. So you can copy your code into Mu and use Mu like this. There are other online editors. Andy showed me Microsoft Visual Studio, I think, yesterday, and then there's Edit Plus, and many of them have this ability. By the way, since we're in Mu, we did not demonstrate, but you can use this to program your microbits. Same thing, you have to add the cyberbot.py module, and the way you do it in Mu is you click on the Files button, and you have to put the cyberbot.py in the mu_code folder. And this is really well explained on their site. They have great tutorials that tell you how to do this. So once it's there, you just drag it onto the microbit, and then you're good to go. And you can use this editor too. So good job, Jack, sticking with it. I'm super impressed that you did that. And it's really makes the point again, someone else just has to look at your code once in a while, get another set of eyes on it. We get stuck all the time in our office with this kind of thing. Good find. Any questions on that? Okay, cool. Yeah, hopefully just little tips. These are kind of tool specific, not so much educational, but they are in the fact that no matter what you're doing with 3D printers, CNC machines, microcontrollers, modern manufacturing, it's all the same kind of issues with different software. So the next thing was Pauline Ritchie sent in a really cool program. It was Imagine Dragons Believer song, and I'll just grab it and copy it into the chat for you all right now so you can have it. Oh, whoops, looks like I actually had a duplicated part of that code, so I'll just blast that out of there. So for those who want to run this code, here it is. I wish there was a file paste ability. Okay, so looked at this, and there must be a better way to do it, and it's the power of lists. So you've been using functions to simplify things. So Pauline and I rewrote this code this way. And we put the notes and then the duration of all the notes into 2 lists. And then we made a loop. Actually, it's a while loop, and we just stepped through each of these values. We incremented it. First, we set the index 0, and then we stepped through it, and we grabbed from the list the note and then the duration. Then we incremented the list index. So then we get the next note, next duration. And this is the same song. So I provided a first hack at it, then we went back and forth, and then 3 emails later, she had produced a wonderful version of it. So these are really lists, and I think they are the equivalent of arrays. And there's that code if you want to run it, just put it in chat.
Again, I wanted to also point out that the first iteration of this code that you guys ran, I'm seeing that it was 38 lines of code long. This that you see here, even with those 3 comment lines at the top, is only 20 lines of code long. So you're able to see more of the program on a single screen whenever it is in this list or array style format. And then to Carl's question about are those arrays, you can think of them as an array if that's where you're coming from. As Ken said, they're lists in a data structure known as a linked list. That allows you gives you a little bit more flexibility than a traditional array does. But that's, getting technical on the inside terminology of it. You can just think of it as an array. And I still trip myself up and call them arrays, but they're technically lists.
Yeah, and again, to start learning more about using all these different coding techniques, the BBC MicroPython documentation is really good, and that's in our slideshow up front. There's a list of links that I find really useful that pretty much are your whole class set of links. Everything you need is there. There are like 10 of them. So
we have another question in chat, wanting to get a copy of the escaping corners code. You said earlier you wish there was a way that you could share a file in there. Actually, Ken, if you just drag a file into the chat window.
Oh, okay.
That'll just make it available to everyone.
I'll do that. Once we get Andy rolling, then I'll paste in all these codes.
Great.
Yeah, great. Yeah, so this is really where the fun begins when you can start programming in Python, you know how to add the library, then you're really on your way. So next item up was Bly Hartley was working with the microbit as well as a Cyberbot and produced some pretty cool examples. Let's see if I can, and anyway, he had a question. This question was about attaching to microbit pins. I'll just give this, anyone know where the focus tool is in this camera? I'll give it a quick look. If I don't see it, I think we'll be okay. Oh. Manual focus is not on, but it still is very clunky. Okay, well that works well enough. All right, so yeah, what you're looking at here, this is the coronavirus you're arrested robot, which you saw the other day. And I have done something different here where I've connected to the IO pins of the microbit. So there are 3 here in these big ring terminals that you can easily get to. And I soldered wires to them. And you would do this if you want to use some kind of support, some sort of library or module that's available for the microbit, but not in the Cyberbot import. And we have most everything you need for the robotics tutorials are in cyberbot.py, but occasionally you'll run into some other things you might want to do. And you don't have a ton of I/O pins to get to this way, but there's also not a ton of memory in the microbit, but there's enough. So I just soldered those wires like you can see here, just straight to those little pads. You can also use, I think you can get an alligator clip in there, or you could use like a banana plug. And the library used here was in the, it's on the BBC microbit website, it's just called NeoPixels. Okay. So questions from all of you before we go into cybersecurity that we may not have answered? We could spend a couple minutes there. How did anyone want to show off a robot that they've got working? If you do, just make some noise and we can get to you.
We have one that that does a backup beeper if anybody wants to see that.
Oh yeah, and I have your YouTube video, which I could show up. But if you want to show it in front of your camera, you could do that too.
Sure. Yeah, I think I have a different program flashed on it. Why don't you just put the YouTube video up?
Okay. Let's see there. Where did I put that? And while I retrieve Adam's video, did everybody have success with whiskers? Let us know. All right, I see some thumbs up. Cool. Did anybody move on to infrared object avoidance?
Got a few of those.
And
Yep.
While we're getting that pulled up, question came up in the chat, how many students per robot? Ideally, I think most of us would agree, ideally 1-to-1, but sometimes budgets don't really allow for that. So we usually recommend 2-to-1. 2-to-1 you can get by great. That's what we usually recommend with all the nicer materials that we push out when we get that question. You know, you do a pair programming kind of thing where one student works on the robot, the other works on the code, or they can team up on the code, get an extra set of eyes like Ken was mentioning earlier. 2-to-1 can work really great.
Okay, this is not the right video, Adam. Maybe paste it in chat. I think I got a couple links from you. I'll give it one more look. Is this it, Adam? Oh, okay, so I'll enable the sound here.
So tell us what's going on here.
Okay, so we have a backup beeper. When it crashes into things with the whiskers, then it has a little backup beeper before it turns. Yeah, the video is a little choppy, but I can put the link in the chat anyway, so if you want to see it.
I just dropped it there. Yeah, very cool.
Okay, perfect.
Good job. And he can do that because once you set the backwards command in motion, you're free to do other stuff. Okay, so now we're going to
with Andy if he's back from a hangout room.
He is back.
Okay. All right. So I'll introduce Andy. Andy Lindsay has produced many books for Parallax and has written with NYSERC all the cybersecurity material that's available. And he's been doing this for 20 years and has probably instructed, I don't know, well over 5,000 teachers in various places around the world. So Andy's going to show us what he's been working on, which is totally unique. So Andy, passing to you.
All right, well, thank you, Ken. Let's see, the host has spotlighted your video for everybody. So you can all see me right now. And hello.
I need to stop share. Okay, I'm over and out.
Oh, so now you can all see me. So what I'm going to do is share my screen, and let's make sure that everybody can see my screen. Okay, so are you looking at a Cyberbot with, can you see me tilting a microbit? It's currently displaying a little line or a diamond, depending on whether I've got it flat. Can everybody see that? I'm getting thumbs up. Good.
Looking good.
All righty. So the end of our workshops normally hit the cybersecurity subject, and when we have a group of teachers in a single room, what we do is we just kind of do a quick little fun survey of the topics in cybersecurity. And the reason we do that is because it has the information that cybersecurity professionals, teachers will be interested in, but it also has some fun things that at a gee whiz level, even if you're not planning to use the Cyberbot to teach cybersecurity, there's still some fun stuff and some interesting things to learn. So first, a little bit about how this came about. The cybersecurity program, both NYSERC and Parallax, as you've already heard, collaborated on the development of the Cyberbot. And we went to a convention called NICE K-12 in mid-December, and we taught a course there. And one of the questions that came up repeatedly was, this is great. It's we're learning the basics of computing, of robotics, of electronics, but wouldn't it be cool if we could do actual cybersecurity lessons with it? And so Parallax and NYSERC put their heads together and came up with kind of an amazing series of lessons. And the cybersecurity, it turns out that with radios that are built into the microbit, any classroom of cyberbots can establish a little network of radio connected cyberbots that can talk to each other. It's all unencrypted, which is at a fundamental level the way networks and the internet works. Everything's out in the open, and our machines encrypt the communication for us, so that hackers cannot see our personal information and our communication over the internet. And so once we figured out that a classroom full of cyberbots is actually a microcosm for either a network or the internet, then the rest was very easy. And at a think tank in, was it late January or early February, Chuck?
Proud about there.
Well, somewhere thereabouts. We came up with an initial set of lessons, and the interesting thing is that this is actually just a even though it's probably a semester's worth of lessons, it's still a microcosm of what you can do cybersecurity wise with the Cyberbot in a classroom. So we talk about some basic fundamentals in terms of when you type a character on a keyboard, what is that code? What is a string of characters, and how can you use it in your Python programs? Key value pairs are a very fundamental thing. Every time you're in a web page and you fill out a form, it gets delivered to the server as a key value pair. Like there's a key called name, and then if your name is Andy Lindsay and I fill that in, the browser transmits it as name : Andy Lindsay, or name and some separating character, depending on depending on the way the server and the browser agreed to communicate. So key value pairs are important. Addressing, for example, using web addresses. Error handling is a thing that has to do with, for example, if you're using a web browser and it freezes on you. In many cases, that's because something unexpected that the programmer didn't expect to happen happened, and the browser did not handle the error correctly, and so your browser or the code in it didn't handle it correctly, and so it froze. So these are some examples of general internet IT level lessons that are part of the foundation of cybersecurity. Now, when we get to introducing cybersecurity, there are certain attacks that are defended against on a constant basis with basically internet security programs on your computer. Your network and IT professionals at your school are constantly making sure that the network is protected and fending off attacks. And these are job and employment skills that if we can teach them to students at the high school level and possibly even junior high, middle school level in some cases, it gives them a microcosm and some hands-on experience with things that are very real in the larger IT world, but you don't have to set up a special protected network for your students. That the network is already built into a classroom of cyberbots. Are there any questions so far? Sorry, I'm not looking at the chat if that's okay. So just go ahead and interrupt me if you would with any questions that come up as I'm speaking.
That's a good point, Andy. Thank you. Tommy and the NYSERC team are monitoring the chat. You go ahead and keep going. And if anyone has a question, feel free to unmute.
Okay, yes, please just go ahead and shout out your questions or chat them, and Tommy and Chuck will let me know. All right, so some of the lessons we're currently working on, actually many of these are published on our Learn site, and then others are still in the queue. They go through a second, NYSERC wrote most of these, drafted them, and then they go through a second pass inside Parallax with some editorial illustration and other things added, and then they make it to the Learn site. And I'm assuming that there's additional cybersecurity material in the NYSERC curriculum that you saw how to access the other day. Anyway, there's some prerequisites or basics, and these are not necessarily required. What we did was we basically published things like how to communicate with your microbit. Let's see here, it's 8:29. Ken, when do I get to talk? How late do I get to talk till?
You had to ask, you're done.
You're good, Andy. We'll go all the way up till near the hour.
Wow, okay then.
Yeah.
That's great.
5 till at the latest, I'll cut it off.
Okay, great. So, so there are some basics in terms of programming that is a little bit more advanced, and that was something else that we discovered at NICE K-12 is that there is a demand for kind of an advanced level of the Cyberbot, and so that's why we're also filling that niche with this material. So there's some basics in terms of programming and communicating with your microbit, and once you get through that, then there's radio communication, and encryption is when we hit the meat of cybersecurity, or when we start on it. And then there's various ways of having robot contests. And so, for example, if you have too much network traffic and your computer slows down, that's a cyber issue, and it can actually be emulated in the classroom because there may be too much network and traffic, and your robot becomes less responsive. So it gives you a physical way to observe some of the things that, again, that are otherwise network and internet related. And then there's education on some of the attacks that happen on computers, and also the code that is used to defend against those attacks. And again, since a classroom of cyberbots is a microcosm of either a network or the internet, all these attacks can be made by students wearing black hats and defended against by students wearing white hats. And I guess you could say that the teacher's wearing a gray hat and kind of overseeing all this. We also have some fun projects, essentially radio tilt control. There's stuff with compass. There's a few things also in the queue that have to do with, well, let's see, there's the compass, and there's actually a lot more than this. For example, last week I realized that you could actually write code for your microbit to emulate an operating system and actually have the ability to make your microbit vulnerable to virus infections. Now, I want to emphasize that your microbit is not vulnerable to virus infections. It's a script that you have to write and put into your microbit to make it capable of being, infected. But network topology, there's a lot more beyond this that we can do. We're getting this set up first, and then I'm not sure exactly what the plan is for, beyond this, but this is definitely a lot of material. Now, if you're going to be trying some of these because you happen to have a second microbit, and even if you just have one microbit, or one Cyberbot, you can do some of these without the radio connection. Make sure to set your performance to the max, because the Chrome browser needs a lot of resources in order to communicate over the terminal with your microbit. So this is very important. So any of you who normally you go down to your system tray here and you click the little battery and then you drag a slider so that you're at best performance. So that's going to be important if you want to try these. So the first one I wanted to show you is from some of the foundation material. This is the computer microbit talk lesson. This one is published, and you can actually click any of the tiles. Whenever I have a tile up, it means that it's already published on learn.parallax.com. And so when I click the tile, it gives me a link, and I can go ahead and follow that. And the tutorial opens up, and we can read through this and then, turn to the next page. And this shows us what to expect as we do the example code. And there's lots of good information about terminals and how they work. And it goes on and on like this, and it's all step by step. And we also have, hopefully this is visible, we have some animated GIFs on how to, for example, get connected to your terminal. And so that's an example of a link you can follow to a tutorial that's embedded in the slide. Now, also embedded in the slide are the code examples. Now, when we have a code example and it is embedded, usually the code example, you can click it and it'll actually take you to the page where the code example is featured. However, to make life easy, what I did was I set it up for a direct download. And so if you look at the speaker notes, hopefully everybody can see the speaker notes. If you can't, in the slideshow, simply click View and select Show Speaker Notes. And what you can do with that is, once you see the speaker notes, there's a code example, and it ends in .hex, and you can click it. And then when the link appears, follow the link, and it'll take you to a download screen. And you can then download the hex file. And when you do that, it's going to appear in your downloads. And so here I have the microbit editor going. And if you've got your downloads sorted so that the date modified is showing the most recent, you'll have a countdown timer as a hex file. And hex files are a great way to store your entire project. It stores the Cyberbot module as well as the code. And so I can drag this. Actually, this one doesn't need the Cyberbot module, so it doesn't have it. But if you do have an example that has the Cyberbot module in it, it's stored inside the hex file. So you can simply drag that into your editor, and then you'll have the code. And provided that you are connected to your microbit, you can load the code. And then after the code is loaded, you can click the serial connection, the open serial button, and it should display. If it doesn't, you can try clicking Control D to reset. And Unfortunately, one of the things that happens sometimes is that I've got so much going on my computer with the slideshow and the video that my resources may be too sparse to have a good demonstration here. Let's see if, here we go. Okay. So this particular example shows or basically asks you, hey, enter the number of seconds to count down. It's a countdown timer, and so I'll count down for 5 seconds and then press enter. And then it says enter the message after countdown, and so I'll do hooray. And then it displays the countdown, and yeah, I'm sorry for the choppy display, but hopefully you get the idea of what it looks like. And when your computer isn't doing broadcasting a video conference, it'll look considerably better than this. Do we have questions so far? Everything okay?
Looking good so far.
All right. So this is an example of how you can essentially use the speaker notes. Like I said, every example program is available for download in the speaker notes. And so this first one is actually at the tail end of the lesson. So this computer microbit talk, at the very end, this is input print for applications. And so this is the countdown timer page. And so this takes you step by step through entering the code, and it shows you what to expect and so on and so forth. And normally it's at the end of a class, so we like to have it so that you can try out things that are at the end of any given lesson because they're fun. And since it's all documented, you can go back whenever you want to go ahead and start at the beginning of a lesson. Another topic is ASCII codes. ASCII codes are the actual number values that get sent from, say, your keyboard to your computer. And they have a lot of importance in cybersecurity because you know, a lot of text is transmitted across the internet, and some of it needs to be very secure. And so one of the basic foundations of that is encryption. And one of the basic foundations of encryption is simply understanding, hey, when I type the A key, it actually is represented for my computer as the number 65. And that is so important, in fact, that we have lessons on doing that. And so this little script right here, and again, it is accessible through you can simply download the script and run it. Let's see, I'll talk about this script and I'll just explain what's happening in the script, and then please download these and try them out if you like. So this particular script is one where you go through the lesson of typing in individual characters and actually seeing their ASCII code. And so A is 65, capital A, capital B is 66, capital C is 67, and so on. And then, of course, by going to the Learn site, and incidentally, in the speaker notes, I put a link to this reference page. You can look up the ASCII codes or just have fun by prompting enter a character and seeing the ASCII value. And the tutorial goes through, you know, what is this ORD function that takes that character and converts it to an ASCII number or to a number that gets stored in the ASCII variable. And so those are all very important foundation things that students need to know in order to do cybersecurity. Now, then in terms of encryption, we have two things. One is called a cipher, and the other is called a key. Those are the most important parts of encrypting data. And so this is a modified version of that program where students, they basically add a few lines of code. And in that few lines of code, what the cipher does is it takes that number 65, and in this case adds 10 to it. So now the number is 75, which happens to be the letter K. And that is a really important piece of encryption. It's the most basic and fundamental way to encrypt character data, is to say, oh, well, gee, what is the value that we have for A or B? And let's add some number to that to throw everybody off. And in a classroom situation, that will be enough for some students at the beginning. So another tutorial that we have is radio basics. And this takes you step by step through programming the microbit to send and receive radio messages. And when you have a Cyberbot plus at least one extra microbit or a classroom full of Cyberbots, you can do some really interesting things with the radio. And at the end of the cybersecurity radio basics tutorial, which is right here, again, I clicked the little badge and then it's taking me to the website. So at the very end of the radio basics tutorial, we have this kind of, I added this because it's fun for kids, you know, that they seem to always want to do texting. And so instead of unidirectional text, which is introduced earlier, or rather is a step past one direction text, this is bidirectional texting. And so you've got one student with one microbit or Cyberbot on one, and they have a terminal open on their computer. Then you have a student with a second microbit and a second Cyberbot, and they have their terminal open. And this is where it starts to get interesting, because see here. Hello, Ken?
Yeah, you're good.
Okay. So this is where it starts to get interesting. You can download the code, and this code is bidirectional texts.
And while Andy gets this ready, I'll let you know this is a lot of fun in class. And who knows if it'll work with the video conferencing software, but basically.
Yeah, that is very true. And it looks like I made a mistake on where, oh boy, I think I messed up the slides.
Hey, well, if you want to get that straightened out, Andy, I can demonstrate one of your next codes that I've got queued up. Chuck would need to pass back the share to me, and then we can return to you. Okay, so Andy will sort that out. So what you're looking at here now, I think you guys can all see my display again. Can you give me a thumbs up, please? Okay, cool. So you see like a dozen robots on the left side. So this is an open form of wireless communication. And as a teacher, you can take control over all the bots in the class at once. And I'm going to demonstrate that. And live demos are made to fail. Especially when we're using Chrome in this way and Zoom, and we're sharing audio all over the place and we're on wireless, whatever. But let's see what happens. So this example, Andy will start out unencrypted, wide open. We'll just send commands, and then the tutorials will step you through locking down the communication through the use of channel IDs and encryption. So I'm going to type in some numbers to give to the robots. I'm going to start out by going forward. Whoops, 1 second. Okay, see those guys turn? So actually the second value did not go across right. So I'm going to try to go backwards. And for some reason, once we have the zoom on, this does not work as well. Yeah, for example, that did not work. Well, we'll try a simple. I get kind of these key repeats. Okay, yeah, so you get the idea. There's a 3-second maneuver. Pretty cool, right? Yep, all your bots are ours. Okay, Andy, go back to you.
Sure. Okay, do I need to reshare my screen?
You
Yes.
do.
All righty. Okay, so I am still looking for the encrypted version. It should be somewhere in my downloads, so that'll only take a second. And so what I'm doing right now is I'm loading the chat program into both of my microbits and opening the serial for both of them. And so normally this would be, each student would have their own computer. And so hopefully if I type in hello, there we go, and nothing's happening here. Okay, reset, flash, open serial. Man. Okay, well, I'll just back this up then and show you a little video clip I recorded of the chat program. And oh, hey, maybe my microbit is back. Let's try one last time. Boy, yeah, this is. I apologize for this, everybody. I did not expect the computer/network to behave quite this way. So here is an example I recorded ahead of time where essentially I have two microbits connected. They're both on the radio, and every time I type something into one of the terminals, it appears on the other terminal. And so students can use this to communicate with each other. And the interesting thing is it's open to other students. And so the question comes up, well, gee, how do I protect my information? And the answer is, well, step one would be encryption. And so would step 2, 3, 4, 5, 6, 7, 8, 9, and 10, as you get to increased levels of encryption to essentially deal with increased levels of attack. And so here is an example that, so this is without encryption. And so you can download your terminal chat through microbits A and B, put them each on a different microbit, and ideally be connected to separate computers, and you can text back and forth through that. Problem is that everybody can see that with their microbit if they're also running the program. Now, the interesting thing is, remember how I said you can add 10 to each character? Well, if you add 10 to the letter H, to its ASCII code, you get R. If you add 10 to the letter E, you get O, and then LL is VV, and then Y is O. So each time this program right here says, okay, what's the ASCII code for the character you just typed? All right, let's add 10 to it. That's our cipher. That's our encryption algorithm that's being applied to the letter H. Okay, we get back an R, and we'll send that out. Now, if you, the other student on the receiving end, don't have the key, which would also be 10, to decrypt it, all you get is something that's not really easy to comprehend. And so the encryption and sniffing lesson, or to step one, how to protect yourself against having your communication sniffed, is a very simple cipher that takes the letter H and changes it to R, and so on and so forth. And if you're also running the same program with a key of 10 on the receiving end, guess what? Instead of ROVVYI, you see hello question mark. What do you guys think of that? All right then. There is lots of background information.
Quick comment, Andy.
Yeah,
Before
go ahead,
you proceed, When we've used this open chat in classroom, it's totally fun and crazy. The students will start just going berserk, and I don't know how you have to handle that as a teacher, but let them have their fun. All the messages will come across.
Well, and that was one of the reasons I added that on, is because otherwise the students feel like it's a bit clinical, but you know, adding some fun in is really helpful as a motivating feature. And so so we added that in, and yeah, there's a little bit of controlled pandemonium that has to happen, I feel.
Andy, got a question. Do the students then start trying to guess what those encryptions are? Like
That's
some
exactly
common
right.
numbers?
Well, here's the interesting thing. Now you've done a loop already. You've said for, you know, for a number in range 0 to 26, right? Something like that. So you can actually write a script to search and try to find, you know, to search and watch the communication as you're searching to try to see if there's anything intelligible. So the idea behind cybersecurity is that it's always this kind of leapfrog thing where the hackers are coming up with new ideas on how to get inside something, and the defenders are coming up with new ideas on how to prevent that. And so yeah, I just skipped a step for you. So yes, you can look at ROVVY, and of course, if you're an old hand at this, you'll know right away that it's a Caesar cipher and that you can get inside it. But if not, there's, unfortunately, but it's a reality, more sophisticated ways of getting inside that. And the cybersecurity tutorials cover all of that. DOS attacks, which are overloading the network. See, I made some notes earlier on that. So there are simple attacks, denial of service or DOS attacks, brute force, and key exchange. So basically, even if you can't figure out the key, there's a way to copy the communication and then resend it to basically, it'll have the key inside it. And so there's unfortunately mischief that can happen there. Oh, no, I'm sorry, that's replay attacks. Brute force is what I was talking about writing a script to figure out the key, and then replay attacks is a clever way to get around that when the key or the algorithm is not immediately apparent. And so these are the kind of things where students get to see attacks and also defend against them and understand how that whole universe works. There's lots more background information, like this is an example of key value pairs, which I mentioned earlier is the way that browsers and servers exchange information. Like when you're typing in your name in a survey, it becomes a key, like name, and a value, like Sir Lancelot or Andy Lindsay or whatever. And then maybe your address instead of score is 1,000. And so that's in the dictionary primer. Let's see here. This is, and then we get to radio data. And in radio data, what we do is we use those dictionaries. So when one microbit is taking data and sending it to another, it's actually using a dictionary to transmit that data. And this particular program is a repeat of the countdown that I showed you at the very beginning, where you type in 5 and it counts down and then it displays the message you type in. Exception handling. That, again, I mentioned as something that freezes web pages. It's another if not done correctly. So this is a thing that Python supports, and so we have a tutorial on it. And then we get to keyboard control of the robot. Well, step one in any wireless application is to normally do it with a wire first. So this is really fun. I highly recommend this one. You can basically run the terminal control start tethered script, and you can basically type in a left and right wheel speed and then the number of milliseconds to execute the maneuver, and it'll go ahead and do that for you. And then there's the wireless version, where we take the components of the script that allows you to type in the keyboard, and then essentially we type in the keyboard, it gets converted to a dictionary, sent out over the radio, received by your Cyberbot, and without that tether, it still executes your connections. This is a great one for solving mazes, having contests, and then this is also a point where the students start essentially hacking each other and trying to defend against those cyber attacks. Ken already showed you this because he was broadcasting to 20 cyberbots. Ken, is that correct?
Yes, that's correct.
Okay. And then Ken, do you also have the, did you already show them the tilt controlled gripper?
I'll do that at the end.
Oh, okay. Well, and then how about the tilt controlled cyberbot with the little compassy things?
So I've got the tilt controlled gripper ready. I could demo that right now.
Okay, because it essentially uses all this technology, the dictionaries, the radio transmission. It's currently not encrypted because Ken's in the safety of his own office. And okay, while you're bringing that up, I think I'll just say a couple more things and just jump in when you're ready. Okay, so this is the script for the keyboard control, and then this is an example of what it looks like on your terminal. And then this is a script for the wireless keyboard control, and this is an example of what it looks like on your terminal. Incidentally, all of these are building on previous programs. So the countdown application over radio is what this started as. And the tutorial shows how to essentially take the working tethered code and then insert the relevant parts of it into a larger radio communication program. How you doing, Ken?
Ready to go.
All right. Chuck, can you pass it over to Ken?
Got it.
You hit stop share. Yep.
Okay.
Sorry about that.
Yeah, and this is what Andy wanted to demo. And this is combining all those pieces that he just showed you.
Ken, we can't quite see your tilt.
Oh, okay.
It's just going a little fast because of the delay with the video, Ken.
Yeah, I'd like to point out that there's a little second hand that is showing which way you're tilting your microbit, and then that second hand is also repeated on the microbit that's on the Cyberbot. And again, those are using that same web browser type communication where everything gets put in key value pairs in a dictionary and transmitted over the radio. And what that does is it makes it super flexible so that you can, essentially it took about 20 minutes to add that feature in the first time without any tutorials.
That was great, Andy. Thanks for the whole presentation.
Yeah, thanks for having me.
So all those are posted. He's about 2/3 the way through this. Can they be used for distance learning? I actually think they can, because you need one robot and one microbit. So when you compare this to the competition model robots, those same dollars can cover all your students quite nicely. Sales point. So why does all this matter? Here's what's happening with hardware. You all know about IoT. Every time you buy something now, it comes with an app. And who knows what your DJI quadcopter is uploading back to China when you fly it around. So we have to know how these things work. And unfortunately, our country's not even making all these products anymore. So we have to really skill up. Half of the products that are going to be made will be connected to the Internet of Things. And the basic of that runs on hardware using some of the things that Andy showed you. So let's just get students basically familiar with that. From a deeper perspective, industry looks at all kinds of attacks that can happen to hardware, through power supplies, various ports that are open, chips that get installed that might be open. So it's an interesting topic. Proceeding on. We're going to briefly show you a couple of demos. Oh, Chuck, I'd like you to show some of the NYSERC Python tutorials. Could you bring those up for a moment?
Yep.
Okay, and then I'll be ready.
Okay. So again, we mentioned earlier in the week, all of our content is hosted on a Canvas learning management system. hosted at nicirc.instructure.com. If you don't have access, head on over to nicirc.org and click on curricula and then curricula access and fill out a form. Again, it's free for all K-12 teachers in the country. We want to give this stuff away, so register and get access to all of it. So what I've got is I've got 3 pages pulled up here, and the first one is what we call Cyber Fundamentals, and it's appropriately abbreviated to Cyber Fun. And we got some Lego content for elementary, middle. We've got Make Code, which is block style program for the microbit, which is elementary, middle, early, high. And then we've got Python for the microbit, which we were having a chat in the, chat before about, when is this content appropriate? Definitely elementary, middle schoolers are running with Make Code and doing good things. High schoolers are learning programming with Make Code. We like Python, obviously, because of its text-based capabilities. So we're bringing Python in at the high school level. But we've seen some schools demonstrate marked success with Python in middle school because it's such a nice, friendly language with good syntax and good structure. And then Cyberbot, obviously, can only run Python. We can't use block Make Code on Cyberbot. So this is Python-based content, which we're, again, appropriately considering for high school, and some middle school opportunities where appropriate. So within the microbit Python section, we've got, over a dozen lessons that are using Python to demonstrate skills you can do with the microbit. And here's a couple that I pulled down. This came right off of Canvas. So lesson 6, we talked about compassing comparisons. There was some reference to Compass in Andy's talk, and what we've got here are some teacher notes. So this is the stuff that the teacher would read before the class period, get familiar with the content that's going to happen. If you stay, a day or two, a lesson or two ahead of your students, you're going to be good to go. We know how busy you are, so we've written teacher notes just to give you an idea of what's going to happen in this lesson. Some of the commands you're going to use, some of the other operations, and then we're going to give you some sample code. And we formatted it so that you can copy and paste from this PDF into the online text editor. But we've also got worksheets for students. So here's a Compass worksheet where they're going to do some conversions, and they can start to learn the difference between your cardinal directions, which is your north, south, east, west, and your numerical directions, which is 0 through 360. And then there's a version 2 of that, which deals with specifically the directions that we want to indicate in the heads-up display on the microbit. So there's 2 versions of that. And then we also provide source code if you wanted to have this as a handout for students. Another lesson, again, same format. We've got master notes. This is a project called Tug of War. So this is a game on one microbit where one student gets one push button, the other student gets the other push buttons. So we introduce push buttons here and the tactile switches that we can also build into the Cyberbot with the programmable breadboard that's on there. And we give you some samples of the code. And again, there's the source code. But we also have a worksheet for the students to consider how do loops work. So this might be where we introduce specific loops, for loops, while loops, and I thought there was do while, but just fors and whiles. And then of course the source code. Where does the Cyberbot come into play? And of course we have called cyber literacy. So cyber literacy is our 8th, 9th grade intro to cyber engineering. We have cyber literacy ported out to the Bobot, the ShieldBot with Arduino, and the Cyberbot. And here we're doing all Python-based activities with the Cyberbot. So there was conversation before about how do I get my wheels to rotate at the same rate. That's a digital command. Once you've centered your servos, again, which happens in a dedicated lesson in cyber literacy, in order to get your maneuvers tuned so that it goes straight, that's a digital correction. So I have to change it in my code. And we go through a whole day of how to do that here. What came up in the chat, the cool thing about tuning your maneuvers is it's different on every bot because every bot's servos are slightly different. And that's a manufacturing issue that comes from the source. So this is an important lesson for students to own their code, right? Not just use the generic source code, but now they have to make subtle changes so that their bot does what they want it to do. We go through the basic builds in Cyber Literacy 1, whisker navigation, infrared navigation, and then some creative challenges using those those adaptions. In CyberLit 2, however, we're doing a lot more. We call this systems engineering. So we're bringing multiple components together on one platform. And with the Cyberbot, we go back and we start again with LEDs in motion. We go back to whiskers. And then we really start going off into some nice advanced concepts. We talk about binary and how to turn your bot into a binary counter. We put push buttons back into play. And then we build a bank vault. So we start talking about cybersecurity here. And students are encouraged to brute force into a locked Cyberbot. And then we come back the next lesson, which might be a week later, and we build a bot that actually is going to tap in and use algorithms to try and break into that other bot. And it's a really cool introduction into brute force security. We go back into infrared. We do some advanced infrared work. This is all available on Parallax's site too, how to use the infrared programmable remote control with the Cyberbot. We bring in some additional sensors like an accelerometer, which the microbit has, and then we turn it into a moon rover so that it doesn't dangerously roll off of cliffs. Once it starts tilting, it'll back up and change course. An airport runway design using multiple LEDs. We bring in a little soldering into place because we want to take these sensors now and bring them down to the mat so that our bot can follow lines. There's a kit for that. There's a QTI kit, but we thought we might as well introduce a skill of soldering so that they can customize the stock parts and be able to do line following with the stock kit and not have to bring in that extra cost for the classroom. If you can get the QTI kit, it's a really great adaptation to do line following. But then the ultimate challenge here is a minefield. And what we do is we hide magnets under a foam board. So you dig out the foam board, you bury magnets in there, you put a tape line or an electrical tape line over the course, over the magnets, and then you have the bot follow the lines with phototransistors, sense for magnets with Hall effect, which is a magnetic detector, and then the bot, it's up to the students what they do. They sound light, they make lights go off, they sound an alarm with the speaker, they go backwards and around, but a really great kind of capstone challenge for our CyberLit 2 kids. But this is content, again, we're giving it away, so by all means, sign up and take advantage of all the stuff we're doing with Python in the classroom.
And Chuck, when you run your summer classes, is it this content that you're showing us?
Yeah, so we've got some cyber literacy workshops coming up. Let me turn my camera back on to me. So we've got some cyber literacy workshops coming up this summer. Most of the stuff we're doing in partnership with you, Ken, so it's going to be intro level, getting you ready. All of these lessons on Canvas provide master notes, and my team's available at any time if you have questions on how to implement in the classroom. But once our school year starts rolling, we're happy to come back and support with some dedicated lessons based on some of the material in cyber literacy.
Awesome. Okay. So we're going to do a 2-minute sales pitch on you. And this is totally opposite of timeshares. I've never sat through a timeshare presentation, but if you do a timeshare, they make you sit for 4 hours and then you get 2 days. We give you the robot first and then we sell it to you. So just briefly, what do you need to use these in class? All right, so as you look at the tutorials, and my screen share is up, right, Chuck?
Yep.
Okay.
I think so.
They're divided up like this. There are prerequisites, and those prerequisites are identified in the main lessons. And then there are...
Just a second.
Yep, Andy?
I just want to point out, you can see right in the center of Ken's screen right now, the cybersecurity radio basics. This is all the lessons that are on the learn.parallax.com site. And I just wanted to mention that every single lesson that I talked about that is posted is accessible from that particular webpage Ken was just on.
Cybersecurity radio basics. Okay, so what hardware do you need? For the prerequisites and main lessons, you need the kit that you have. That's just the Cyberbot kit. And then for the projects, there's a line follower, a ping sensor on a servo, and then the infrared remote control. And these you can get either a la carte, kind of like Mexican food, or you can get them in this 12-pack plus. So this is the easiest way to start a class out. You get 12 sets and you can have 24 students coding. And that includes also rechargeable batteries, a bunch of remotes, line followers, replenishment kits, all that kind of stuff. Or you can just get the robot alone like this. Both ways are popular. Lately, this 12-pack has really picked up speed. It even comes with a cool classroom banner. So your choice there. After the class, we will contact you. We do these for free, but these robots have been supported by NYSERC and supplied by them. Thank you very much, NYSERC. Chuck, Tommy, all of you have been wonderful, Kevin, to help out this program.
Yeah, and the outcome has been incredible.
Yeah, I mean, there are 80 of you here, which is amazing. So we appreciate that. If you want to stock them, you can get them through us, get them in your class. And there are those 2 kits I just showed you. And if you're upgrading old robots, we have hardware to do that as well, no problem. Like, shouldn't call these old, they're just as good. Many of you use Bow bots or the Shield bots, and you can move between these quite easily with some hardware. For support, you are absolutely not left alone when you use our hardware. I just really want to drive that home. Many of you called the educator hotline this week. If someone wants to dial the number just to be sure that it works, that would be really cool right now. But we answer this about 12 hours a day. This is a no-nonsense way for teachers to get straight to us when they're in class and they're just, feeling deflated or can't get through something. We will help you with your problem. No matter what it is, you can call the educator hotline. You don't have to wait for an email. See, getting a call right now, as a matter of fact. Yeah, that's Kevin Knowlton. How funny. From NYSERC. Figures he'd be the first. So yeah, use that or just drop us an email. We're totally accessible. You can also get support through education@parallax.com. One place I like to frequent online is the BBC Microbit group on Facebook. You'll see I'm always dropping our material in there as it's produced. Even in advance, and just kind of getting people's reactions and seeing how they're going to take it. So that's the BBC Microbit Facebook group. I think it's the most active one.
Again, I want to highlight that if any of us do call you, you're going to look at us, laugh at us, and then hang up on us. Or is that just what you do to Kevin?
Just to Kevin. Maybe I shouldn't have done that.
Kim, we've got a couple questions coming in the chat here, asking about can you upgrade the activity bots?
That's the only robot that's not upgraded. It's not an easy thing to do because it uses different motors. Good question. Any others? We will actually contact you afterwards. We do not do sales pressure tactics on anybody, but we will ask you if you're going to proceed, if you're looking at this. And those are important questions for us to get answered. Just tell us the truth, what you're thinking. You can't afford it, you might do it, whatever. And that helps us decide how much marketing we can do with Cyberbots. So, Parallax does not spend a lot of money at conferences. Done that for years. We've gotten smart about this. All of our funds for marketing go into free hardware for teachers. We just want to get them trained. And so we're able to find you on the internet quite nicely. Well, should we talk about awards? Let's see if this works. We got a lot of interesting stuff. I don't even have them all here because you flooded me with at least 100 pictures and huge videos I couldn't even download. But I did grab a few of them. There's some pretty good pets. This is Paul Dunn's dog. Kevin Knowlton has a similar dog to this.
How do you say Kevin Knowlton's dog's name?
Lanyap.
There you go.
Hey, there we go.
If you want to bring him forward, we'd welcome his participation. Jeff Monteith sent in some really funny stuff. He was working with this penguin child thing. And there we go. There's Lanyap in Kevin's lap saying, hey, put me down. Yeah. When is the Zoom meeting over, he says. Jeff Monteith.
Say hi, D.
Hi.
Oh, yeah, okay. There he is. There's the penguin child. So that kid that you're looking at gets out of bed after his mom thinks that he's down for the night, and he integrates whiskers and light following sensors. So penguin child. This is a random one from Liliana, but funny, worth sharing. It's her biggest fish. I think her only fish, she said. Anybody know what kind of tuna that is?
That's the yellowfin, right?
I think so, yeah. Beautiful. Couple fails out there. Here's a good one. I've never seen this one done. Offsetting the servo motors would have been interesting to see that run. Oh, here's a really nice one. Hopefully this video works. John Gerstenberg's Curious Cats. Seen a lot of robot-animal interaction through the years. Certain dogs just go berserk with this. Cats usually know right away it's not organic, and they back off. Not interested. This one could not give up. Even parked his butt in front of it.
When I was toying with one of the Cyberbot prototypes, my little dog was not having it. She attacked it.
Here's a cool one. It's a baby chick.
Chicks dig Cyberbots.
Who provided this one? This one is pretty cool. Yeah. Really funny. And then Adam, we showed one of his videos, and let's see if this, whoops. One of them we already demoed. Let's see if we could bring up the other one. Yeah, so he's got a lot of interesting animals too. He's got, not to mention his kids, a couple of reptiles. I don't know.
Those bearded dragons?
Yeah, I'm not sure what they are. And there's a chicken. Okay, that stopped. And there's even a turtle. Let's look at the turtle.
Those are geckos.
Those are geckos. Okay.
They're much bigger than the wild geckos I've got around my house.
Ruby the chicken. So having a lot of fun over there. What else do we got here? Midnight and Bailey. I thought it was the same dog. High level of enthusiasm. Jeff's penguin locator. Do you hear the audio from the video?
It's very faint.
Oh, okay. Yeah. So I'll just narrate it. It's got a penguin on the LED display, and then the robot goes into penguin locating mode, which is basically bouncing off things, but when the penguin shows up with a bright light, it tracks the penguin. Good job, Jeff. That was cool. Blay Hartley submitted a number of things, integrated LEDs and whiskers. And this is an example where he's using a particular type of LED that was connected directly to the microbit called NeoPixels or WS2812s. We sell those in little 10 packs. Good job on that, Blay. Ed Von Hout, he made his own tilt controller using the accelerometer and using the radio. Whoops. Let's go back there. Things are just taking off on me. Okay. Let's see if that one plays. And he used arrows. And if you create projects like this, we can share them, send them to us. Mostly they'll wind up in our social media, but we can also put them on the Learn pages if they're documented well enough. Good job, Ed. And now we're getting into some interesting stuff too. This is from Heidi Lent. I thought this was timely. A way to communicate with students.
That's really cool.
Yeah, that's pretty nice. I mean, that's simple mechanical project, fun. Heidi, you're a winner, by the way.
Hey, I wanted to highlight too those floor tiles that she has. That's like what I had in my classroom. And those are 12 by 12 tiles. So if your classroom has those kind of tiles on the floor, you've got a giant Cartesian grid that you can have to have your students either align along one of those straight lines to make sure their bots are traveling straight. You can also do kind of a rise over run mapping, different formulas as they go forward 2 tiles, then over one tile or 2 tiles, whatever. You can play with different mathematical functions like that and show how it translates into real life. Those tiles are super handy for that kind of stuff.
Darren Wilcoxon, he integrated infrared, whiskers, and auto park. So this robot drives through the boxes, keeping itself centered. And what he did is he pointed the infrared emitter receivers out to the side, so it's centering itself.
Oh, that's really cool.
Yeah, it's a good project. And then when he gets to where it's dark, the light sensor turns it off and plays Happy Birthday. So autonomous driving vehicle.
It's going to find you. It's going to sing Happy Birthday.
Yeah, it's pretty cool. I mean, and do we have more, or was that the end? There were more. Like I said, I couldn't integrate all of them because there were so many and didn't have a lot of time. But our winners here are Bly Hartley for repeated projects and the use of the LEDs. Jack Huang by just failing miserably with if-then-else indentation, but then winning even bigger by figuring out his problem and getting it to work, not giving up. So all the pieces work individually. You have to make them work together. Good job, Jack. Darren Wilcoxon and Pauline Ritchie submitted a great project. She's also a winner with her Believer song. And then Jeff Monteith with his penguin stuff. And then Heidi as well. So good job to all of you.
Bravo.
Yeah, it was a great class. What do we have coming up next? We will not host a Cyberbot 2 class until the fall. So we're spending a lot of time right now just training about 500 teachers on the Cyberbot level 1, we'll call it. And we didn't figure out what level 1 was until we started doing it, but we will have a level 2 that'll focus more on coding. And then NYSERC has classes going on this summer. If you already have them, you already have a robot, you can actually, I think you can just keep taking Parallax classes again. You'll see different things sometimes, and you can get to those classes through parallax.com/events, but you're now part of our email group, so we'll notify you anyway. And NYSERC's classes, we've also linked there. I'll just give that a quick look.
Yep, nyserc.org/PD is where we're hosting all of our upcoming professional development events. And there's a link there to our Eventbrite page. And most everything coming up is free. So just like what you got here.
Well, and internet is stalling out, so we won't be able to take anybody there.
You can imagine.
Yeah.
I put a link in the chat.
Oh, great. Thanks. Yeah, so any final questions, comments from anybody? Okay, we see you want Cyberbot 2, definitely coming up.
I will say that I was answering a question before about programming languages and appropriateness and what's the difference between one bot to the next. And the easiest thing for me to explain the difference between the bots is pick your favorite programming language. So, you know, we talked in the chat about Bobot is programmed in BASIC. The ShieldBot with Arduino is programmed in a Arduino variant of C++. And the Cyberbot is programmed in Python. The ActivityBot has Blockly, it has C++, it has Spin. So basically, you know, pick your language, and then that's the bot that's going to follow. The cool thing about it is they're all the same form factor. They have the same programmable breadboard, solderless breadboard, and it's just language differences. So.
Very well summarized, Chuck. Okay, then, well, this concludes the Cyberbot training session. Thank you all so much for joining. We had a lot of fun, learned a lot with you, actually. I picked up some new skills this week, and want to thank NYSERC again for contributing, the robots and the team here to help us out.
Thanks for hosting, Ken. It's been our pleasure to participate. Thanks, everybody.
Everybody have a wonderful spring and summer, and see you soon.
Thanks for hanging out, everyone.
Thanks, everyone.